Okay, today we're talking about double angles. Double angle identities. Alright, example 1. We're going to use the double angle formula to rewrite cosine of 6x in terms of 3x. Okay, so that doesn't seem too hard because 6x is twice 3x. Does that make sense? So let me do it like this to make it really easy. So let's let theta equal 3x so that 2 theta is 6x. Okay, does that make sense? Because when I use my double angle formula, I need my 2 theta, right? I need my 2 theta. So when I do my double angle formula, whenever I do my theta, it's 3x. So we're going to do this. We're going to take a look at cosine of 2 theta is equal to. Now, we got a choice of any of these. It does not really matter, except it kind of does because we've got, wrong notes. Here we go. So we've got 3 choices for cosine. You see it? I got cosine squared, sine squared, 1 minus sine squared, or 2 cosine squared theta. Now, which one am I going to use? Well, look at the question in terms of what? Cosine, right? Right? That's my question. So I'm going to pick the third one because it's in terms of cosine, right? So this is going to equal my 2 cosine squared theta minus 1, which we're going to rewrite theta as 3x. So now I'm going to take and put my 3x back in here. So I'm going to rewrite this as 2 cosine squared of 3x minus 1. And that's it. That is cosine of 6x is equal to 2 cosine squared of 3x minus 1. Hopefully that was as easy as I thought it was. You guys okay with that? Was that as easy as I thought it was? Good. Thank you. Okay. All right. Example 2. All right. So example 2 is going to take a little bit of work, but I can do it. So I want cosine to the fourth minus sine to the, I want to somehow make it equal to a cosine of 2x. So what I'm going to have to do is try and reduce this thing as much as I can. So I want to get rid of I want to get rid of the fourth power, and I want to get rid of the fourth power because there's no exponent here. So I'm going to reduce it. So I'm going to take it from a squared to no power, and from a squared to no power. Okay, so I want to reduce it. So cosine. Let's see. Cosine. If I want to reduce cosine, I've got to use this formula. So I'm going to go ahead and rewrite it first as cosine squared x cosine squared x, because that makes cosine to the fourth, right? You okay with that? Minus a sine squared x cosine squared x. And do you guys mind if I use thetas instead of x? You guys like theta? I like theta better. Okay, I'm going to probably change it to thetas. I like thetas better. Theta, 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 theta. Okay? Now, I've got a formula. So cosine squared, let's see, cosine squared is that one. So I'll rewrite this one as a parentheses. I'll make it a 1 plus a cosine of 2 theta over 2 times another one of these, because I got 2 of these. I got cosine squared, cosine squared. So here's my first identity for cosine squared theta. So let's write it down again. 1 plus cosine of 2 theta over 2. Okay, minus. Well, I've got a formula for my sine squared, so I'm going to take my sine squared and write it as a 1 minus cosine of 2 theta over 2. So minus, I'll go parentheses, and I'll rewrite this one as a 1 minus a cosine of 2 theta over 2 times another, because I've got sine squared, right? Oh my gosh, it's Monday. Sorry, sine squared, so I got another, squeeze this in, 1 minus cosine 2 theta over 2. Squeeze it in. Okay, so what I did is this. I'll back us up. Cosine of the fourth is cosine squared, cosine squared. All right? Sine of the fourth is sine squared, okay? All right? Cosine squared is this identity, 1 plus cosine of 2 theta. Then I got another one, so I've got cosine, here's the identity, and here's the same identity, okay? Sine squared has an identity. It's 1 minus cosine of 2 theta, and I wrote it twice. How am I doing? Now, big old FOIL problem. Let's have fun. Big old FOIL problem. So if I do a big old FOIL problem, so I'm going to go 1 times 1 is 1. And I'm going to shortcut this because that makes 2 of those. You guys okay with 2 of the cosines of 2 thetas. And then plus a cosine squared of 2 theta all over 4. Okay? Scoot over a little bit so you can see it. Okay, here's what I did. 1 times 1 is 1. And I knew I got a cosine 2 theta and another cosine 2 theta, so I got 2 of those, right? Now put your phone away.
Sorry, I'm working. There's that one.
That times that is cosine squared, okay? Cosine times cosine, all divided by 2 times 2 is 4, okay? We'll do the same thing on the other side. Let's FOIL that out, okay? Same thing on the side, so I'll have then minus. And I'm going to put this in parentheses because I got to make sure I bring the negative through, okay? I'm going to put the whole thing in parentheses because when I'm done, I'm subtracting this mess. So subtract whatever this is, okay? So then minus, I get 1. And then I'm going to have 2 of these. So I'm going to have a negative 1 cosine of 2 theta, another negative 1 cosine of 2 theta. So I'm going to have negative 2 of those, okay? So I have a negative 2 cosine 2 theta. And then this times this makes a positive cosine squared, okay? So I got another positive cosine squared. Positive cosine squared 2 theta all over 4, okay? How am I doing? Okay, they basically have a common denominator, right? So we can actually subtract them or add them. So if this will help us a little bit. If I make this negative come through, I've got 1 minus 1, right? Nothing. So the ones will be gone, right? 1 minus 1, gone. Phew. Right? Now, we got to be careful with this one because this is really going to be a 2 cosine 2 theta minus a minus, which is really plus, right? So I'm going to have 2 plus 2 makes 4 of these. You get that? You guys see 4 of them? So I'll have 4. So I'm going to have a 4 cosine of 2 theta, right? And then I'm going to have a, I got to scoot it over so you can see it. So now I'm going to have a cosine squared minus a cosine squared. Those cancel each other out, right? Minus cosine squared minus cosine squared. Those cancel each other, okay? So then boom, boom, cancel, cancel. And then all over 4, right? I think I've done it. Because the 4's cancel. And I've got it equal to 2, well, cosine of x. I can go back to cosine of 2x. So I proved it. Not too bad? Thumbs up? Okay. I'll wait till you're done. I'll turn the page, okay? That was not bad. We just had to be careful when we subtracted, right? Okay, turn the page. Sydney, I'll wait for you. You got it? Okay, turn the page, okay? Now, this one's a little bit different. So first of all, when you read this question, cosine of x is equal to 2/3. Let's make a cosine of theta. I should be making these theta. Cosine of theta equals 2/3. I like theta better. And theta's in quadrant 4, okay? So when you read that, what's the first thing you should do? Do I? Let's find quadrant 4. Okay, let's find quadrant 4. There's quadrant 4, right? And what should we put in quadrant 4? Let's put a triangle. Let's put a triangle in quadrant 4, okay? There's my theta, right? Now cosine is the adjacent over the hypotenuse. You guys agree with that? So that means in this triangle, my 2 is right here, and my 3 is there, okay? So I know in a triangle that cosine is the adjacent, so there's my 2, and 3 is my hypotenuse, okay? And that's a right angle, okay? So what are we missing? Opposite side, right? So Pythagorean's theorem, right? So let's go 2 squared plus b squared equals 3 squared, right? Right? So we want to find our hypotenuse. I've got 4 plus b squared equals 9, right? I've got b squared equals 5. I've got b is plus or minus the square root of 5, but which one is it? Is it plus or is it minus? Minus, because you got to go down to it. Everybody agree with that? So it's minus. It's minus square root of 5, okay? Now it gets easy. That gets easy. So minus the square root of 5. Okay, so let's look at our formula. So my formula for sine of 2x, so sine of 2 theta, is this formula here, okay? So I'm going to write that down. So I'm going to go 2 sine theta cosine theta, right? You got to pay attention because this is super easy, but if you don't pay attention, you will not get it, okay? Super easy, okay? What is sine? Sine is opposite over hypotenuse. So instead of writing sine, so writing this right here, I'm going to write negative square root of 5 over 3. Okay? So I'm going to go 2 times, let's see, where's my pen? Negative square root of 5 over 3. And cosine, we already know cosine, but you're right, it's the adjacent of the hypotenuse, right? 2 over 3, okay? So then this is just cosine is just 2 over 3. So if I simplify this, I get negative 4 square root of 5 over 9. And that is the value of sine of 2x, or sine of 2 theta, okay? Not too bad. Okay, we're going to do the same thing with cosine of 2 theta. Now we got a couple of choices. We got 3 choices. Okay, so which formula do you want to use? Yeah, you want to use the third one? I like that choice. Yeah, you know, why did you use this one? I love that choice. It's cosine, and cosine's got the, there's no square roots of 5 in the cosine. Sine has square roots of 5. They will all work. You can't go wrong if you pick any of these. So if we can pick any of them, Eduardo, which one do you want to pick? Third one, okay? I like it. You cannot go wrong. If you pick any 3 of these, you'll get the same answer. Eduardo said, I think this one looks easier. So Eduardo said, let's use our 2 cosine squared theta minus 1. All right. So it's easy. Okay, 2. What's cosine? What's cosine of the angle? 2/3, right? 2/3 squared, because cosine's adjacent over hypotenuse, or it's right there, right? Minus 1. We could fix that. 2 times 4/9 minus 1, right? Which is 8/9 minus 1, which is negative 1/9. You okay with that? You will have to do this in calculus. You really will. Okay, now, tangent. Okay, well, we only really have one formula for tangent. So tangent, we're going to have to write this formula down here. Okay, that's the tangent formula. So I'm going to write it's equal to 2 tangent theta over 1 minus tangent squared theta. Okay, so now tangent is opposite over adjacent. Good. So I'm going to go 2 times, now I'm going to go negative square root of 5 over 2, all divided by 1 minus negative square root of 5 over 2 squared, right? Which is going to be, 2's cancel here, negative square root of 5, right? But on the bottom, we're going to have a 1 minus 5/4. And I'll go through this with you slowly. Okay, so you see a double negative? No. You see a double negative? No. Because you're going to square the negative, makes it positive, which means it still stays negative. Want to show that again? You see a negative squared is positive, but then this still makes it negative, okay? Square root of 5 squared is just 5, and 2 squared is 4. Okay, does that make sense? Okay, now, this is the same thing as 1 minus a negative 5/4 should be a negative 1/4. You guys okay with that? Negative 1/4. So I'll have the square root of 5 over negative 1/4. Right? Flip it, and I get negative 4 square roots of 5. How's that? Okay with that? Fractions. Don't you love fractions? No. Okay, last but not least, and again, I keep wanting to emphasize that if you never take calculus, then all right, awesome, we're just going to have fun doing this. But if you do take calculus, all of these tricks I'm teaching you will help you a lot, okay? All right. Who is it? Sarah? Oh, what's Sarah's last? You know, she's got her head shaved. Sarah's last name. Right, yeah. She came in on Friday and she said, I never thought I'd use synthetic division. I thought that was the stupidest thing. She goes, but we just did it in Calc 2. She goes, thank you. Because I taught her how to do synthetic division, right? It's easy. Okay, example 4. Okay, if I want to reduce it, so we want to reduce it to degree 1, right? Degree 1. So if I want to reduce it, then I'm going to use my reducing formula. So if I go to my formulas, here's my reducing formulas, okay? So I'm going to use my reducing formulas. So before I do anything, this is the same thing as sine squared of 8x times another sine squared of 8x. You guys okay with that? So I'm reducing it some. I went from a fourth power to a square to square, okay? Now we've got an identity for that. So I'm reducing one. I'm going to use the 1 minus cosine of 2 theta over 2. I'm going to use it twice because I've got a sine squared, sine squared. So I'm going to go ahead and rewrite this as a 1 minus a cosine of 8x. But now it's really going to be a 16x over 2. And the reason it became a 16x is because my identity says, yeah, you go from theta to 2 theta times by 2. Everybody agree with that? And I'm going to do that again. I'm going to go another 1 minus a cosine of 16x over 2. All right, how am I doing? Now, I'm going to have to do a little FOILage because technically it hasn't been reduced completely. So if I FOIL, I'm going to get a 1. I'm going to get 2 of these minus 2 cosines of, I'll make it theta. I like theta better. 16 theta plus cosine squared of 16 theta. Okay, how am I doing? All over 4, right? All over 4. Okay, darn it, I still haven't reduced it to a degree of 1, have I? So I'm going to change this one, and I'm going to reduce this one from a cosine squared to a 1 plus cosine of 2 theta. But before I do that, I'm going to tidy all this up first, okay? But I'm going to change this one next, but I'm going to tidy this up first, okay? So if I tidy this up first, I'm going to get a 1/4. You see the 1/4? Minus a 1/2 cosine of 16 theta, right? Plus a 1/4 times my cosine squared of 16 theta, okay? Now, I'm getting there. I really am. I'm getting there. So now I'm going to do one more. I'm going to take my cosine squared, okay? Take this cosine squared here. I'm going to change it to 1 plus cosine of 2 theta over 2, okay? So I'm going to change this into its double angle form. So, okay, ready? This is a 1/4 times a 1 plus cosine of a 32 theta, right? All over 2, okay? Right? Landon said earlier, if this is a 16, then we go to a 2 theta, which doubles it, right? You guys see that? So what a mess. But let's see if we can fix this mess, okay? So then This simplifies into a 1/8. Can you see a 1/8? Can you see a 1/8?
Yeah.
Okay, I got a 1/8 plus a 1/8 cosine, a 1/8 cosine of 32 theta. Now if we include what we have over here, let's see what we have over here. So 1/4 plus 1/8 is 3/8. Okay, if I do that, this 1/4, so way over here, 1/4 and 1/8 makes a 3/8. Does that bother your brain too much? 1/4 plus 1/8 is 3/8. So I get a 3/8. Okay. Now I'd like to put these two together, but they're different, aren't they? They're different. Okay, so minus a 1/2. God, I remember doing this in calculus. I really do. Cosine of 16x. I'm gonna bring it back to x. Plus a 1/8 cosine of a 32x. Wow. Okay, that's it. So the more